People often say 7 is a lucky number, but is there any maths behind this? In this video, I'm going to show that in one case, 7 actually is more likely to occur than any other number, and along the way, we'll introduce the basics of probability. Let's start with a die. I could roll this die and get a 4. I could roll it again and get a 6. I could roll it again and get a 1. Let's create a little table to help us record all of this. I'm going to record two things: the outcome and the probability of each outcome. Now, this is a standard 6-sided die, so the outcomes are the numbers 1 to 6. Well, there are 6 outcomes because there are 6 faces on the die, so as a fraction, the probability is going to be something over 6 because there are 6 possible outcomes. What's the numerator of our fraction going to be? Well, there is only one outcome that gives us a value of 1 out of 6 possible outcomes. So the probability is going to be 1 out of 6. And because this is a fair die, the probability of each outcome is the same. The probability of getting a 2 is also 1 over 6, and so on. Something extra to add is that if we added up all of those probabilities, we would get 6 over 6, which is equivalent to 1. And that means that if I roll this die, it is certain that one of these 6 numbers will come up. So in this case, 7 would definitely not be a lucky number because it's impossible to get a 7. But now we've developed these tools and started thinking about probability, let's move to a case where 7 might be considered a lucky number. Now let's start with 2 dice. This time I'm interested in the total, so I could roll the 2 dice and get a 3 and a 1, which gives me a total of 4. I could roll them again and get a 6 and a 5, giving me a total of 11. And I could roll them again and get a 2 and a 5, giving me a total of 7. Now that we're adding together the values on 2 dice, we've added an extra layer of complexity. So instead of going directly to my probability table, I'm going to create something called a sample space diagram. Down the left-hand side of this table, I'm going to put the numbers 1 to 6, and this represents the values on the first dice. Along the top, I'm going to also put the numbers 1 to 6, and this is going to represent the numbers on the second dice. So if I were to roll my 2 dice and get a 1 on both dice, this would give me a total of 2. I could roll my dice again and get a 1 on the first dice and a 2 on the second dice, and this would give me a total of 3. Similarly, getting a 2 on the first dice and a 1 on the second dice will also give me a total of 3. We might start to notice a pattern here. A 1 and a 3 gives me a 4, a 2 and a 2 gives me a 4, and a 3 and a 1 gives me a 4. In fact, all the numbers in the diagonal going from the top right to the bottom left are going to be the same for every diagonal. The next numbers are all going to be 5s, and then 6s, and 7s, and 8s, and 9s, and then 10s, and 11s, and then 1, 12. Now we know all the possible combinations and all the totals they give us. Let's transfer this into a probability table. My probability table this time is going to look very similar to the probability table from when we only had 1 die. On the top, I'm going to have the total, and on the bottom, I'm going to have the probability. Notice that there are 36 possible combinations of outcomes. However, there are actually only 11 different totals, because some of those combinations give us the same total. The possible totals are the numbers from 2 through to 12. Let's try and work out the probability of getting a 2. Now we are rolling 2 dice. There are 36 possible combinations that we could get on those 2 dice. As a result, all of our probabilities are going to be out of 36, because that bottom number represents all the possible combinations. Now, how many times does the number 2 appear? Well, it appears there, and it only appears once. Therefore, the probability is going to be 1 over 36. Let's now have a look at the probability of getting a 3. Again, there are 36 possible combinations. How many of those combinations give us a 3? This time, 2 combinations give us a 3. Therefore, the probability here is 2 over 36. What's the probability for a total of 4? Again, there are 36 possible combinations, and 3 of them give us a total of 4. So the probability of getting a 4 is 3 out of 36. You'll notice that for all of these, the denominator of the fraction is going to stay the same. It's going to be 36 for every one, because there are always 36 possible combinations. There are 4 combinations that give us a total of 5. Therefore, the probability of getting a 5 is 4 out of 36. You'll notice that these probabilities keep increasing. The probability of getting a 6 is 5 out of 36. The probability of getting a 7 is 6 over 36. However, something changes when we get to 8. There are still 36 possible combinations. However, now there are only 5 combinations that give us a total of 8. Therefore, the probability of getting an 8 is 5 over 36. And those probabilities continue to decline. For 9, the probability is 4 over 36. For 10, the probability is 3 over 36. For 11, the probability is 2 over 36. And for 12, the probability is 1 over 36. You'll notice that this is symmetrical. You might have spotted that we might be able to simplify some of these fractions in the probability row. However, I've chosen not to do this because it allows an easier comparison between the different probabilities. And when we do this comparison, we'll see that 7 is the total with the highest probability. There are 6 combinations that give us a total of 7. Therefore, the probability of getting a 7 is 6 over 36. Let's take a look at each of these combinations now. I could get a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, and a 6 and a 1. And all of these combinations would give me 7. And that's why it could be claimed that 7 is a lucky number. In this case, it's definitely the most likely total to emerge. Whether or not that means it's lucky, I'm not quite so sure. One final thing to point out is if we added all of the probabilities in our probability table, we would get a total of 36 over 36. And that simplifies again to 1. The reason for this is that all probabilities must add up to 1. Any other totals, for example, -3 or 402, are impossible. There's no way we can get that from adding together the values on these two dice. And so they'd all have a probability of 0. So we've addressed the question of whether or not 7 is a lucky number, and also covered some of the basics of probability along the way. And that's it for this week's video. As always, if you've enjoyed this video, leaving a like really helps me out, as it means more people will be able to see this video. And if you want to find your way back for more mathematical content, don't forget to subscribe. Thanks, guys.